All right. Um, so we will be talking about if statements and loops. Let me make sure I have the participants here. Okay. All right. So for if statements, there's an instruction in MIPS that we need to learn, and it's called branch on equal. So this is something that we're going to be spending, a good amount of today's class kind of talking about and doing examples of. It looks like this. First, I'm going to start with the syntax, just like we've done in the past. So it'll be branch on equal, so BEQ, and then there's a register. I'm going to call it register A, and then there's another register. I'm going to call it register B, and then there's something called a label, which we really haven't seen before. So there's this thing called label, and essentially it's a place, it's a location in the code that we can go to. So a label is a location in the code that we can jump to, essentially. And this is the syntax. And let me explain to you how that works, and then we can do a few examples. So the way this works is, if the content of this one is equal to this one, then I'm going to branch to this one, to this label. So this one is called branch on equal. And essentially, if the content of register A is the same as is equal to the content of register B, then we're going to jump or branch to label. So by default, when we have code in MIPS, we go sequentially. We go one line at a time. So for example, if I say add immediate is 0, 0, 10, that's going to put 10 in as 0. Then I'm going to say add immediate T0, 0, 5. That's going to put 5 in T0. And then I'm going to say add, T0, or rather T0 to T0 and put it in T0. So this is really the same thing as, T0 is equal to T0 multiplied by 2. Same thing. So we're adding, T0 to T0 and we're putting it in T0. So of course, in this case, T0 is going to be 10. And then I'm going to do something like branch on equal, and I'm going to say T0 is 0, and I'm going to go somewhere. Let's call this, L1. So that's the name of the label. You can actually give it any name. You don't want to start with numbers. You don't want to use, underscores or dashes. I'm actually pretty sure you can use underscores, but we typically just use, just letters and maybe numbers after the letters. And ideally, we would actually use a descriptive name. So L1 is not really a very good name, but that's okay for now. And here, maybe I can say sub, maybe, I'm going to put something in S2, and I'm going to put S0 minus T0, for example. And then I'm going to say add immediate TS2. Let me actually do add immediate here. And let me add, negative 20. Let me just simplify it. Put negative 20 in S2. And then let me just do that. That's it. And then I'm going to have the label. And the label is going to be here in my case. Of course, this label can be anywhere. But for this example that will demonstrate, the behavior of this instruction, I'm going to put L1 here. And then I can say, for example, add immediate S2, S2, and maybe 5. And maybe what I'm going to do is I'm going to say add immediate S2, 0, 10. So let's think about this for a few minutes, and then we can do more examples. We can even take this code and put it in the simulator, make sure that what I'm telling you is, is correct. let's start with the first one. This one is going to give the value 10 to S2. And I'm going to pause in a few seconds to ask you if all of that makes sense or not. I'm going to actually create a table here. Can I do table? Is there a table here? Here's a table, basic. Okay, basic is good. And what I'm going to do is I'm going to use only 2 rows. Okay, so this one's going to be maybe S2, this one's going to be S0, this one's going to be T0, and that's it. So the value of S2 is 10, so we put 10 here. Does that make sense? Let me get a thumbs up if that makes sense. We're just starting, but I want to make sure that all of that makes sense. Okay, that's good. I'll just keep this column. All right, so right now 10 is in S0, so that means I'm going to put 10 in S0. And then I'm going to put 5 in T0, so I'm going to put 5 here in T0. And then I'm going to add T0 to T0 and put it in T0. So I'm going to say 5 plus 5, and let's put it in T0, so that's going to be 10. And here I'm going to say if the content of T0 is the same, or rather is equal to the content of S0, then I'm going to jump or branch to L1. Now the content of T0 is 10 in this case, and the content of S0 is 10 in this case. So that means I'm going to jump to L1. So that means I'm going to actually skip this line because, this one is equal to this one. And because of that, I need to go to L1, and L1 happens to be here. L1 can be anywhere. It can be before, after, but in this case, L1 happens to be here. So I'm going to jump here, and then I'm going to say, I'm going to add 5 to S2 and put it in S2. So S2 is going to become 15. All right. So if I give you this code, tomorrow, and I ask you what is the value of S2 based on, what we did, based on kind of tracing those lines, we end up with 15. Does that make sense? Do you have any questions about this? All right, so I think there is a question. Let me read it. So the line add immediate S2 0 negative 20 is not executed because we branched to L1. That is correct. So because the content of this one is equal to the content of this one, we needed to branch or jump to L1. And that actually made us skip anything between this and the L1. Now I'm going to do another example where we actually do not branch, and we're going to see kind of what that entails. All right, so I'm going to do another example. So I'm going to keep everything. In fact, I'm going to copy everything here, and I'm going to paste it on a new line. And this one did not copy. Let me try again here. Okay, and I'm going to start with empty values, and I'm going to make this one 8. Okay, so I'm going to do the first few lines really quickly because that's kind of very similar to what we did. We're going to put 8 in S2, so there's going to be 8 here. We're going to put 10 in S0, so there's going to be 10 here. We're going to put 5 in T0, 5 goes here. And then, let me actually change that to, let's say 6. So S2 is going to be 8, S0 is going to be 6 here, and then T0 is going to be 5, and then I'm going to add T0 to T0 and put it in T0, so T0 is going to be 10. And right now, I'm going to ask, is the value of T0 equals to the value of S0? And if it is, I'm going to branch to L1. Now, of course, the value of S0 is 6 and the value of T0 is 10, so they're not equal. So what do I do? You're asking. And the answer is, if this one is not equal to this one, then I'm not going to branch. I'm just going to continue sequentially. So instead of branching to L1, I'm just going to continue sequentially. So continuing sequentially means executing this one. So right now, S2 is going to be -20. So that's going to change to -20 because I'm putting -20 in S2. And then I'm saying, let's add 5 to that. And that would be 25, excuse me, -15. So L1 is not going to get in the way when I'm executing things line by line. In fact, I can give each line a label, and that's not going to matter. So I can say L1 here, L2 rather. I don't want to use L1. I can say L3 here. I can say L4. Of course, there's no point in doing that unless you're going to jump to those labels. But the point that I'm making here is that if you do that, nothing is going to happen. I mean, your code is going to just run, sequentially. When we get to here, we're going to make that determination onto whether we're going to go to L1 or go sequentially based on the values of these two. So I guess when we went, what I'm also trying to say is when we went sequentially, we did this one, and of course we had to do this one. We don't skip this one. The fact that we have a label here really has nothing to do with us kind of going sequentially. It's not gonna change anything. All right, do you have any questions about this? So I'm gonna talk about another instruction, and then maybe we can pause the recording and start another recording with examples using these two instructions, the branch on equals and the other one that I'm going to talk about next. So the other instruction is called branch on not equal. So instead of BEQ, it's BNE. And this one is branch on not equal. And I think you probably are guessing how this one is going to behave. So first of all, let's talk about the syntax. It looks BNE, register A, register B, and then we have another label. And the way this behaves is if the content of register A is not equal to the content of register B, then I will branch. So I'm going to branch when they're not equal. And you're going to see why we need kind of both of them, or why it's nice to have both of them. So for example, I'm going to show you a simple example. Add T0, or rather add immediate T0, 0, 5, add immediate T1, 0, this of course should be 5 like that. I hope I did that here. Yeah, of course. The immediates don't have $sign. And here I'm going to say, for example, 10. And I'm going to say, let's say I'm going to do L1 here. And then I'm going to say branch on not equal. Then I'm going to say, T0, T1, go to L1. So if we execute this code, what would happen? Can someone tell me? What do you think would happen? We will branch. That's correct. What I really wanted to hear is that we're going to end up with, let me see, you would execute the first two, then branch back to L1, and then execute again until the values are equal. That's good. Now, of course, based on this code, the values will never be equal. because I'm putting 5 in T0, 10 in T1, and they're not equal. So I'm going to go to L1. So this is actually an infinite loop here, because I'm kind of going to here, I'm putting 5 in T0, 10 in T1, and then if they're not equal, I'm going to go to L1. I go to L1, and this kind of cycle repeats. Does that make sense? That's just an example. It's not particularly kind of a nice example, because you're not going to see code that does that. This is just an infinite loop that really doesn't do much. But it's a good example for us to look at and make sure that we understand. Okay, so we talked about branch on equal. We talked about branch on not equal. And then I'm going to talk about another instruction. But how about I do that after we do some examples of using these two instructions to translate code that contains if statements. So let's do that. And then I'll introduce a third instruction that we actually need for if else. And we need also, for loops. So let me stop the recording here.